Okay, this is going to be a quick demo of the Neuton AI TinyML platform, now part of Nordic Semiconductor, of a complete IoT Edge ML pipeline of data collection, training, deployment, and inference of a machine learning model. And for that, we are going to use this hammer that we will turn into an AI hammer that will infer the type of material that it's hammering. Right? So attached to it, there's a BLE board that we designed based on a Fanstel module for the new Nordic NRF54H20. This board has a few sensors in it, including an IMU that is giving us acceleration and gyroscope data for the X, Y, and Z axis in real time. All right, so let's do data collection. To the right side of the screen, there's a screen capture of a mobile application that we designed for this demo. And let's run data collection. All right, and we can see the stream of data in real time for the acceleration and the gyroscope. Right? What we did is train for different materials or collect different samples for the materials. So let's start with cloth. So we did one session for each of the materials. Did that for a few minutes for each one of them. That was cloth. Let's see, wood. And then we also did this plastic cap. So you can pretty much see the different profiles for the different materials. Okay. Once we have our samples in the mobile application, we can export the data as a CSV. Then we compile all the data and start the training process by uploading the data to the Neuton AI platform. Then we configure our training pipeline, run the training. Since this data set is relatively small, the training took about 3 minutes. These are the results, our 4 classes. When that is done, we have a C library that we can download to deploy in our device by loading in the firmware. Then we do a firmware update. And now the model is loaded on the device and ready for inference. So let's do that. Back to the mobile application, going back to now inference mode. We already have here our classes mapped: idle, cloth, plastic, and wood. Right now nothing is happening, so the inference is idle. So let's try wood first. There's over 99% of probability that this is wood, according to our AI hammer. Now let's do cloth. Again, high probability, 100%, 99% that this is cloth. Then let's try the plastic. Once it settles, again, 99% probability that this is the plastic cap. Right? So it works. We turn the hammer into an AI hammer. Also, one more thing. The cool thing about the Neuton AI platform now being part of Nordic is the support that it has for the different Nordic platforms. So we are running the same project, the same firmware on this device. This is an NRF7002DK Wi-Fi. Now this device is connecting to the Wi-Fi and sending via the internet the data from the same IMU that we have on this board right here. The same IMU that we use in the hammer. So for that, we have a local application that is essentially listening to the port where this device is sending the data via the internet, in this case via Wi-Fi. Right, so let's start the inference model. As you can see, immediately we start getting data from the device via Wi-Fi, right? And we can also run the data collection, and we get the stream of acceleration and gyroscope data in real time remotely via Wi-Fi from this device. This could be anywhere in the world, and we can still collect the data. All right? But that's not all. We can also do the same in an NRF9151 DK. This is the same firmware is running on the device, and this time is connecting via cellular IoT, LTE-M, to the internet, and we have the same IMU here sending the data. So clear the console here. Let's run the inference model on this device. As you can see, we start getting the data in real time. Right? And this is cellular IoT. And actually, we can even run both devices at the same time, and we get data from the two devices simultaneously. All right, so we've shown the complete pipeline for data collection, training, deployment, and inference using a BLE board, a Wi-Fi DK, and a cellular IoT DK. All right, that's all we have for now. Thank you.